Welcome back. Congratulations. It's the last video lecture. This is 9.0, Pharmacy Information System Usage and Application. Alright, 9.1, Pharmacy-related computer applications for documenting the dispensing of prescriptions or medication orders, such as maintaining the electronic medical record, patient adherence, risk factors, alcohol, drug use, drug allergies, side effects. A, computers. Okay, so believe it or not, you have to know like the general basics of a computer. You may be asked one or two questions at the most on the PTC VA exam. Mainframes. These are very expensive and powerful large computers used mostly for data crunching and setting up large networks. However, you will never see one in the pharmacy. 2, dumb terminals. This is a type of computer usually without a hard drive and allows multi-user capacity to access the same pharmacy software system. 3, mini computers. These are similar mainframes used by a company through local area networks. 4, microcomputers or personal computers, PCs. So these are the types of computers used at home or work and is generally the type seen in a pharmacy business. They are standalone systems that run pharmacy software and manage data from a larger source, like a mainframe at general headquarters. So it could be like a multi-user system with 4,000 pharmacies on the same system, like Walgreens, CVS, Rite Aid. And so these systems include a mouse and a printer. Those are peripherals, right? A printer is a peripheral. A mouse is a input device, though. Okay, a mouse is really not considered a peripheral per se. A printer is, though. A mouse and keyboard are considered input devices. Monitors, and then the central processing unit. So every computer, even your iPhone or Android, has a little CPU in there, the central processing unit. That's the brain of the pharmacy. That's the brain of the computer. 5, software. So hardware is the computer, the printers, the keyboard, the scanner. Those are all hardware. Software, this is the written instructions as compared to the hardware, telling the computer hardware exactly what to do. So operating systems are software operating systems. So these instructions govern the basic operation of the hardware. So it could be a Mac operating system or Windows or Linux. Those would be like operating systems. B, software applications. These support the pharmacy operations and the users, such as pharmacists, technicians, and clerks. Let's go to page 2. Computer input devices. So these are the devices that input data, such as the keyboard, the mouse, the scanner, the barcode reader, and touchscreen and light pens. Those are computer input devices. Computer output devices, well, these include monitors or displays, printers, and speakers. And they could also be considered peripheral devices too, right? 8, modem. So these are basically obsoleted these days because most retail chains and whatnot have their satellite. They have a satellite attached to the building. And they allow but modems allow the pharmacy computer to communicate over a network with the insurance company computers. So these days, the most communication to the insurance company is done via a satellite network. 9, memory. So there's random access memory, which is a form of computer data storage which stores frequently used program instructions to increase the general speed of a system. And then the other type of memory is ROM, read-only memory. So this is the type of non-volatile memory where data is stored like on a hard drive or CD-ROM. Okay, so a hard drive or CD-ROM is called ROM, right? Read-only memory. And then you have random access memory, which is RAM, and that's very volatile. That's moving all the time. So your computer system that you buy has so many RAMs in it, so many gigabytes of RAM, and RAM can be really expensive. 10, storage. So this is the home in a computer for data, and it's usually read-only memory, ROM, and your hard drive, for instance, stores information. The processor, so this is the brains of the computer, the CPU, which is the central processing unit. And the faster the CPU, the faster the computer processes data. 12, the interface. So that is a connection between two or more computers on a network. Okay. B, health information standards. So standards are necessary to gain uniformity in processing data and also keeping patients' healthcare safe, as well as securing their private health information. It ensures the interchange of electronic information within the healthcare community. 2, pharmacies need standards which provide security and consistency when communicating electronically with hospitals, physicians' offices, labs, patients, and caregivers, including long-term care facilities like SNFs, skilled nursing facilities. Standard development organizations, page 3. 1. NCPDP, we already discussed this earlier. Type this in or write it in. NCPDP stands for National Council for Prescription Drug Programs. National Council for Prescription Drug Programs. So this is the only standards development organization that focuses on pharmacy services for each step in the prescribing process. It also establishes e-prescribing standards known as Scrip. And you will see more e-prescribing as you enter the pharmacy field because more and more physicians' offices are starting to adopt that technology. It really reduces error rate because you don't have to read this illegible writing from the prescriber's office. Remember that NCPDP also provides reject codes. We talked about that in the last lecture. So it's a standardized development, standards development organization. And it's good that we have something like this because it makes our lives a lot easier. Scrip Standards. So these are standards that facilitates the transfer of prescription data among pharmacies, prescribers, intermediaries, and payers. The current standard supports messages regarding new prescriptions, prescription changes, refill requests, prescription fill status notification, prescription cancellation, medication history, and transactions for long-term care environments. 3. Pharmacist Services Technical Advisory Coalition, the PSTAC. So this consists of 7 pharmacy organizations that were established to improve the coding infrastructure for pharmacy billing and to secure a place for pharmacy in the electronic data interchange, or EDI. D, Pharmacy Informatics. Pharmacy Informatics focuses on the use of information technology and drug information to maximize medication usage with patients and plays an important role in reducing errors and increasing medication treatment outcomes. E, e-prescribing. So this is a paperless computer-to-computer transfer of prescription information among prescribers, pharmacies, and insurance payers. It connects health providers, patients, and agencies in real time and can include medication history and messages regarding new prescriptions, prescription changes or cancellations, refill requests, and other prescription information. Page 4. Demonstrates efficiency with time savings, reduces medication errors because you don't have to read some illegible handwriting, decreases pharmacy costs, improves prescriber and pharmacy administrative efficiency, eliminates handwriting interpretation errors, really important, reduces phone calls between the pharmacist and the prescriber because the pharmacist say, hey, dude, I can't read your writing. What kind of drug are you writing for? What strength? So it eliminates a lot of phone time. Phone time is a killer in the pharmacy in terms of efficiency. And it reduces data entry, creates electronic records, and speeds up refill requests. 4. E-prescribing tools can include software programs as well as hardware such as personal computers, handheld and wireless devices, and touchscreens. 5. The disadvantage is the transaction fee the pharmacy incurs with each prescription it receives. There's actually a transaction fee, and it varies from pharmacy to pharmacy. E-prescribing is one of the integral steps to achieving broad use of electronic health records, which is called EHRs. E-prescribing reduces prescription errors in a variety of healthcare settings. F, electronic healthcare record, the EHR. This is where all hospitals now use EHRs. EHR includes patient demographics, progress notes, problem medications, vital signs, medical history, immunizations, lab data, radiology reports, and advanced directives. G, EPHR, electronic personal health record. So this is generated by physicians, patients, hospitals, and pharmacies, and is controlled by the patient or legal proxy. It can be used by pharmacies in providing medication therapy management. Proxy just means a substitute, right? 9.2, databases, pharmacy computer application, and documentation management such as user access, drug database, interface, inventory report, usage report, override reports, diversion reports. Diversion means like stealing drugs or drugs that are getting diverted somehow out of the normal procurement process, or maybe it's getting stolen off the shelf. Controlled drugs are getting stolen. That's diversion. Page 5. Compounded physician order entry. Computerized physician order entry. Computerized physician order entry. So this is the portion of a clinical information system that enables a patient's care provider to enter an order for medication, clinical laboratory, or radiology test, or procedure directly into the computer. Most advanced systems have real-time clinical decision support, such as dosage and alternative medication suggestions, duplicate therapy warnings, and drug-drug and drug-allergy interaction checking. Access includes biometrics such as your thumbprint, your eye, retina recognition technology, and the maximum amount of relevant information is on each screen. Mobility is maintained through both mobile and stationary devices and system responses that are fast. B, point of care. So this is a place where the pharmacist and patient attempt to address, identify, resolve, and prevent drug-related problems. It may be mobile, like in a tablet, or smartphones, or stationary, like a desktop computer. Stationary, meaning in one place. Telepharmacy. This brings pharmacy care to patients when it is not possible to bring the patient to the pharmacy setting. So that would include like video conferencing or maybe audio conferencing. And it's used to provide real-time counseling and is cost-effective. D, technology and the blank HIPAA, right? Do you remember what HIPAA stands for in the lecture? You even had a separate lecture for that. Type it in and write it in. Health, Insurance, Portability, and Accountability Act, HIPAA. Health, Insurance, Portability, and Accountability Act. 1. HIPAA requires that identifiable or protected health information be held confidentially. Please know what Pgce stands for. That is a common question on the exam. Pgce stands for protected health information. Not personal health information, protected health information. That's Pgce, know that. 2, it allows patients to have better access to their medical records. And 3, prescriber order entry complements technology with HIPAA. 6, number 4 above, patient information is portable and allows information stored on the internet to be moved between systems. E, documentation. Coding systems are used in the documentation of drug-related problems and interventions. 2, documentation principles. Unique patient identification, like when recording or accessing information. B, accuracy throughout information capture, report generation, and during transfer between systems. C, completeness, minimum set of information to complete the incident, observation, or intent, and meets all legal, regulatory, and other requirements. D, timeliness, requires healthcare documentation during or immediately after the event in memory. E, interoperability, across documentation systems. It enables practitioners to capture, share, and report information from any system. F, retrievability. It's a use to standardize titles, formats, templates, macros, terminology, abbreviations, and coding. It enables authorized data searches, indexing, and mining of data. G, authentication and accountability. Uniquely identify persons, devices, and systems that create or generate info and that take responsibility for info accuracy and timeliness. H, auditability. It's when insurance comes in and audits your records to make sure you didn't commit any fraud. It allows users to examine basic information elements such as data fields, audit access, and disclosures of Pgce, and alerts the user of errors, inappropriate changes, and potential and security breaches, and promotes performance metrics. 7, let's go to the top here. I, confidentiality and security. This is adherence to related legislation, regulations, guidelines, and policies throughout the documentation process, and alerts users to potential confidentiality problems and security breaches. F, ambulatory pharmacy computer functions. So this is a pharmacy database with drug file, the physician file, clinical monitoring, payer and insurance information, and interfaces with other systems that include patient information, prescription processing, pharmacist verification of orders entered by technicians. Management functions include generating reports, distribution reports, financial reports, workload data, and file maintenance such as drug files. G, patient monitoring functions. So this is also known as the Clinical Decision Support System, or CDSS. Patient monitoring functions include A, therapeutic duplications. It detects drugs in the same pharmacological therapeutic classification. B, drug allergy interactions. It discovers a drug identified as a drug allergy. C, drug-drug interaction. This is the most important. It identifies medications that may cause problems if taken together or simultaneously. D, drug-food interactions. It informs the user that a drug may cause specific problems if taken with certain foods. E, drug-disease interaction. Drugs that may cause problems with a medical condition. F, drug lab test interactions. These detect medication orders that may interfere with specific drug tests. G, intravenous or IV compatibility or incompatibility. It checks med orders for potential problems with physical incompatibilities and stability. Let's go to page 8, role of automation. So, the general means that machines are used to perform work. A, used to include storage, packaging, compounding, dispensing, and distributing medications. B, it's used to replace labor-intensive tasks. C, it can reduce medication errors, improve documentation, and increase authorized access to both medications and information. D, benefits include increased productivity, accuracy, drug use control, and improved patient care. E, primary use in pharmacy is to count, package, and label dosage forms like the Scrip Pro robot. F, may be centralized or pharmacy-based or decentralized like nursing units. G, can repackage medications from bulk or use overwrapping of unit dose medications such as the dosist machine. I, centralized inpatient automation systems. 1, these are located in the central pharmacy and used to improve manual filling of unit dose cards, and they also use barcode recognition. J, decentralized inpatient automation systems. These are located in patient care unit and often contain floor stock medication, supplies, and controlled substances. And it's designed to solve medication management problems such as lost billing charges, pilferage, narcotic diversion, and poor record keeping. And it's used to dispense medications, return medications, and record medication waste. And it also uses barcode recognition. So this is like the Pgce machine. K, work lists. Let's go to page 9, the final page. Work lists are used to perform a variety of pharmacy tasks and is usually printed daily or as needed. And examples include the unit dose cart fill, cart fill updates, IV pick, and IV fill updates and labels. Finally, L, technologies used in a pharmacy. 1, automated dispensing systems. This is a system that stores, dispenses, charges, and inventories medications. 2, barcodes. Barcodes on medications identify the drug, its dosage form, and its strength, and it obviously improves accuracy and it eliminates mistakes. 3, robotics like the Scrip Pro. A centralized system that uses barcoding technology, a network of computers, a conveyor system, and robots to pick medications according to a patient's profile or order entry by a technician. 4, automated compounding devices, so these would be in a hospital. These are computerized pumps that are used to prepare IV admixtures for both adult and neonatal total parenteral nutrition, otherwise known as hyperalimentation. And this device contains pumps that add the base solution, electrolytes, and other ingredients, like nutrients. And then 5, paperless charting, which uses an electronic patient medical record number. Okay, that ends the blueprint outlines that we've just covered. So these are the 9 sections that the PTCB, Pharmacy Technician Certification Board, has placed as far as competency, what competency levels that you need in the 9 sections. And we've just covered them in all these video lectures. So what I want to say to you now is make sure that you print it on the website all the PDF resources, like abbreviations and common abbreviations and medical terminology, etc., etc. There's a bunch of resources. I want you to hard copy print all of those. You have to know those. The other thing is now after you've done all the PowerPoint lectures and the video lectures, is that you can begin to start doing the exams. After, of course, the math section. So if you've already finished the math section, which are PowerPoint lectures, and you've done a lot of the math worksheets, now you can start to do the full practice PTCE, Pharmacy Technician Certification exams that we've developed for you. And these exams, when you take them, is where you're going to put it all together. You're going to learn a lot. If you haven't learned a lot from the PowerPoint lectures and from these video outline lectures, the exams, the 90-question exams, is where you're going to put everything together, and you're going to learn a lot from those exams. We've had a 100% pass rate from people who've taken all of our exams and got really prepared to actually sit for the PTCB exam. Okay? Good luck with everything. We hope to see you. If you need any personal one-on-one tutoring, we do offer that in a 2-exam review price and a 6-exam review price, and that's on the website. So thank you for hanging in there, and we will see you in a bit.